Imagine a universe where stars blaze out in an instant, or never shine at all, where atoms crumble or galaxies fail to come together. Now consider our own universe, an extraordinary cosmic balance delicately maintained by around 20 fundamental constants. This is the concept of fine-tuning, where even the slightest change in these values could render the cosmos unrecognizable and life impossible. Let's begin with gravity, governed by the gravitational constant. If this constant were even minutely stronger, stars would collapse into black holes before they had a chance to nurture life, a precision measured at an almost unimaginable 1 part in 1040. Next, consider the electromagnetic fine structure constant, roughly equal to 137. A mere 4% deviation in its value would mean the atoms essential for carbon and oxygen, and therefore life itself, would never form. The strong nuclear force, another crucial parameter, shows us that a 2% increase would extinguish stars in an instant, while a 5% decrease would leave the universe devoid of heavy elements. Similarly, the weak nuclear force delicately balances stellar fusion, an explosive phenomenon. Even an adjustment of 1 part in 1010 could either convert all hydrogen to helium or stop the vital process of elements escaping dying stars. The ratio between electrons and protons is just as critical. A slight shift could cause atoms to either collapse in on themselves or fall apart completely. The minuscule difference between the masses of neutrons and protons, only 0.1%, is essential to stabilize atoms and permit chemical complexity. Consider the cosmological constant, a parameter so finely tuned that if it were 10 times larger, galaxies wouldn't have been able to form. Similarly, the density parameter, balanced to 1 part in 1062, determine the shape of the universe at its very inception. And the baryon-to-photon ratio, set to 1 part in 10th9, plays a key role in the availability of matter for star formation. The entropy per baryon must be just right, too high and no structure can emerge, too low and thermodynamic processes lose their drive. Even the primordial density fluctuations, those minuscule variations of about 10^5, were essential for the formation of galaxies. Dark energy density, making up about 68% of the cosmos, also sits at a critical juncture. An increase would have stymied the birth of stars. Why does our universe operate in 3 dimensions? It turns out that only 3 spatial dimensions allow for stability in orbits and wave behaviors. The Higgs field's vacuum expectation value, setting particle masses, must remain within a tight margin. A 10% shift would wreak havoc on chemistry and star formation. Likewise, even the top quark mass is precariously balanced. A 20% alteration could trigger a cascade leading to the collapse of our universe. Neutrino masses, though tiny, sculpt the very structure of galaxies. And the staggering difference between the electromagnetic and gravitational forces, roughly 1036, allows atoms to stick together while gravity gracefully molds stars and galaxies. Lastly, the interplay between Planck's constant and the speed of light enforces the delicate dance between quantum physics and relativity. These 20 constants and conditions are not mere numbers, they are the cosmic ingredients that make our universe habitable. Alter just one, and everything, space, time, matter, and even the possibility of inquiry, would unravel. Are these precise measurements mere coincidences, signs of deliberate design, or hints at a multiverse of possibilities? The debate continues, inviting us to reflect on the profound mystery of a universe balanced on a razor's edge, where chance and necessity intersect to create the very fabric of life.
Thanks for listening to the Wonders of Science channel, where curiosity meets discovery. Stay tuned for more fascinating insights into the mysteries of our world. Keep exploring, and until next time, never stop wondering.